This video is about Maclaurin series. A. The function f is defined by f of x equals e to the sin x power. Find the first two derivatives of f of x, and hence find the Maclaurin series for f of x up to and including the x squared term. F of x equals e to the sin x power. F prime of x equals e to the sin x power times cosine x by chain rule. Then f double prime of x equals, we got to do the product rule of this function. F times g prime equals f prime g plus f g prime e sin x prime times cosine x plus e to the sin x power times cosine x prime e to the sin x times cosine x times cosine x plus e to the sin x times negative sin x. Simplify equals e sin x times cosine square x minus e to the sin x times sin x. Then we will make a table to figure out the Maclaurin series for f of x up to and including the x squared terms. Now let's fill out this table. F of x, f prime of x, f double prime of x. Then substitute 0 into each function. We do know sin 0 equals 0, cosine 0 equals 1, f of 0 equals 1, f prime of 0 equals 1, f double prime of 0. This is 0, so here equals 1. X nth power over n factorial. Check the coefficient of nth derivative of f of 0. We have 1x, x squared over 2 factorial, which is x squared over 2. 1x, x squared over 2. Multiply each other. 1x, x squared over 2. So for Maclaurin series of f of x equals e to the sin x power equals 1 plus x squared over 2 plus. Let's go to B. Show that the coefficient of x to the third power in the Maclaurin series for f of x is 0. We do know in the Maclaurin series, the coefficient of x third power is the third derivative of f of 0 over 3 factorial. So we need to figure out the third derivative of f of 0. We know f double prime of x equals this. So we will take one more derivative of this function. Third derivative of f of x equals, remember product rule for this function. e to the sin x prime times the cosine square x plus e to the sin x times the cosine square x prime, then minus. Whenever you see minus, we will use a bracket for more than one terms. E sin x prime times sin x plus e to the sin x power times sin x prime. Work this out. Equals. From here, e to the sin x power times cosine x by chain rule times cosine square x. Then plus e to the sin x power, this one, times 2 cosine x times the negative sin x by chain rule. Then minus bracket. From here, we will get e sin x times cosine x times sin x plus e sin x times cosine x equals e sin x times cosine x to the third power minus 2 e to the sin x cosine x sin x. Distributive property minus e to the sin x power times cosine x times sin x minus e to the sin x power times cosine x. The third derivative at x equals 0 equals. Remember the rule, sin 0 equals 0, cosine 0 equals 1. So we have a 1 minus, since we have a sin 0, this is 0. Sin 0 here, this is 0. Then minus 1 equals 1 minus 1 equals 0. Therefore, the coefficient of x to the third power in Maclaurin series is 0. Let's go to C. Using the Maclaurin series for arctangent x and e to the 3x power minus 1. Find the Maclaurin series for arctangent e to the 3x power minus 1 up to and including the x to the third power term. In the formula chart, we are given tangent x equals this. Remember, we need to figure out Maclaurin series up to including the x to the third power term. For arctangent x equals x minus x to the third power over 3. Then we stop. E to the x power equals, given here, 1 plus x squared over 2 plus x to the third power over 6. Then e to the 3x power. Substitute 3x for x. 1 plus 3x plus 3x squared over 2 plus 3x to the third power over 6 plus simplify 1 plus 3x plus 9x squared over 2 plus 27x to the third power over 6 e to the 3x power minus 1 equals 1 is gone. 3x plus 9 over 2x squared reduce plus 9 over 2x to the third power. Therefore, for arctangent e to the 3x minus 1, we will plug in this for e to the 3x power minus 1. Arctangent 3x plus 9 over 2x squared plus 9 over 2x to the third power. Then we will substitute this for x in this function. 3x plus 9 over 2x squared plus 9 over 2x to the third power minus 3x plus 9 over 2x squared plus 9 over 2x to the third power. Then third power over 3. Remember, we only need to figure out the Maclaurin series up to x to the third power equals 3x plus 9 over 2x squared plus 9 over 2x to the third power, then minus. For this binomial expansion, only 3x to the third power is the term with x to the third power. 3x to the third power over 3 equals 3x plus 9 over 2x squared. 3x to the third power is 27x to the third power over 3 is 9x to the third power. Combine like terms minus 9 over 2x to the third power, and so on. This is the solution to question C. Let's go to D. Hence or otherwise find this limit. We will use the result from A and C. Limit as x approaches 0 of f of x equals 1 plus x squared over 2, then minus 1 plus. For arctangent e to the 3x power minus 1 is here. 3x plus 9 over 2x squared minus 9 over 2x to the third power. Simplify limit as x approaches 0 of x plus x squared over 2. 3x plus 9 over 2x squared minus 9 over 2x to the third power. When we plug x equals 0 to the top and the bottom of this rational function, we will get 0 over 0. So we can apply L'Hopital's rule. Limit as x approaches 0 of 1 plus x. Denominator 3 plus 9x minus 27 over 2x squared, and so on. Then we plug x equals 0 to this rational function. we will get 1 over 3.